Next, we're going to welcome to the virtual stage Ryan Chi. Ryan should appear here in just a moment. Ryan is the Principal Worldwide BD GTM Leader at AWS. He's going to be educating us today on the cutting-edge world of AI-driven, cloud-based product engineering. Thanks so much, Ryan, for being here. I'll turn the mic over to you.
All right. Can you hear me okay? Richard?
Yes, coming in loud and clear.
Awesome. Awesome. Good morning, good afternoon, everyone. My name is Ryan Chi. Thank you, Rachel, for the introduction. I'm from AWS Emerging Technologies. Really glad to be here today at the Future of Engineering Summit. And I want to thank Dinara and organizers for the invitation. And it's very exciting to be here today with all of you who are pushing the boundaries of AI for engineering. And today we are going to talk about agentic AI, especially how it's reshaping the cloud-based product engineering area. So whether you are an engineer, you are an architect, you are a product manager, or you are someone who is evaluating where to invest in I think you will leave here with a good picture where the technology is going and what you can start doing today. Okay. Okay, this is a quick agenda. We are going to go through 5 areas. Firstly, we want to define agentic AI and multi-agent systems, what they are, why they are different from the generative AI tools, many of you probably already using. Secondly, we'll be looking at the real challenges organizations are facing when they're moving from POC to production. Okay, and then we'll explore the multi-agent tech stack, especially cloud-based tech stack, specifically designed for engineer and design workflows. And then I'm going to walk you through 2 industry use cases. And then finally, I'll close by an outlook of where the technology is headed in the next 2 to 5 years, because the next wave is already forming. All right, let's start with the definition. What is AI agent, right? This term got thrown around a lot. I know different people, different organizations have different definitions. So I just really want us to be working from the same foundation. At AWS, we define AI agents as autonomous or semi-autonomous software systems that can reason, plan, and act to accomplish goals in the digital or physical worlds. Okay, what that really mean in the practice, right? So unlike any regular foundation models, which is essentially a very good text or token predictor, an AI agent can do something, right? It can sense and interact with its environment, such as the APIs, the tools, the database, or even other agents. It can take high-level objective and then break it down into executable steps and then carry those steps further. Okay, you can think about the tasks like compiling research, writing code, managing your enterprise applications. These are not like one-shot prompts, right? These are usually multi-step workflow, require reasoning and actions. So these are where agents will shine. Next, you might be asking, hey, is agentic AI just replacement of generative AI? So the short answer is no, because they serve different purposes and they can coexist. You think about, what you're doing with generative AI, right? You're summarizing docs, you're generating contents, you're translating language, you may creating visuals, right? All of those are great for generative AI, but generative AI doesn't take you one step further. Okay. Agentic AI is the one goes one step further because its primary purpose is actually to achieve specific tasks. It's going to solve more complex multi-step problems. Usually those problems are associated with the large data from different systems. They need to make decisions, they need to act on them, right? So we are talking about this type of problem, which typically are good for human to solve. The problems can be like having an outcome which is subjective. Your data set can be really messy, right? You may be using different tools from different systems and you need orchestration system to make sure they work together, right? So here is the key insight. We believe generative AI is how organization can fully recognize the full promise of large language models. Generative AI alone won't do it. Agentic AI will be the one unlocking it. Okay, let me move to the next one. Let's look at some interesting numbers from Gartner, similar to what JL presented before. By 2028, about one-third of the enterprise software applications will be including agentic AI capabilities. Okay. And then 15% of the day-to-day work decisions will be made by AI agent autonomously by 2028. And the third number, this is really the one I want you to sit with. About 40% of the agentic AI projects we are doing today will be canceled by the end of 2027. This is due to the increasing cost, due to unclear business outcome, due to maybe inadequate risk controls. So 40%, this is not a small number, right? This is not because the technology doesn't work. It's because we see a lot of organizations jump into multi-agent system without the right foundations. So the companies that succeed in this area will be the ones who get the architecture, the security, the governance right at the start. This is what we are going to talk about today. Okay, let's dive a little bit deeper on the challenges moving from POC to production workload, right? As you can see in the middle, we have the performance and the scalability. Basically, we are talking about the runtime environment and memory management for AI agents. These are the key factors. For runtime environment, because usually AI agents will work for a longer time, from a few minutes to a few hours. They are not following a predictable execution paths. So in this process, the data type can be massive, and they are calling different tools dynamically. So you need a really specialized runtime environment to handle all of that. Many customers, when they are running their on-premises environment, they usually don't have one of those runtime environment out of the box. Okay. For memory management, basically because large language models, they are stateless by design. Okay. What I mean by that is usually they don't remember anything between the sessions. But for AI agents, you need to maintain the full awareness of your sessions, and then you need to learn from the past interactions. You need to personalize the behavior of the AI agents. So building that memory layer isn't trivial either. Security layer, you need to control the identity and access. You need to fine-grain the controls to make sure the agents can only access the system and the data is supposed to. An agent that can touch everything is generally a security liability. And finally, governance and observability. So basically, monitoring an AI agent system is fundamentally different from monitoring a traditional software. Okay, you need visibility into what agent is reasoning about, not just whether it can produce a response or not. So the bottom line is, for building production-grade agentic AI system, you need fundamentally different infrastructure capabilities and controls. Many of the, organizations, they simply don't have this exist in the standard on-premises setup. This is where cloud is helping customer to bridge. Okay. Now, let me share a framework about the different agentic AI spectrum. There are 4 levels here. From level 1 to level 4, we are talking about increasing business impact and autonomy. For level 1, this is tool execution. You guys know about this, nothing fancy. Many AI systems start from here. Basically, engineer define a library of functions, and the AI agent will determine which function to call and when to call it. Okay. Level 2 is deterministic workflow. At this level, usually the systems follow a structured, predefined procedure, and you need certain real-time, like reasoning, decision-making capabilities. The engineers still have high control of the flow. And at this level, usually the AI agent just work as a flow router. Okay. Level 3, autonomous agents. These are things that are getting interesting, right? Autonomous agent can make independent decisions. They can handle more complex problem solving. As an engineer, you don't need to predetermine the workflow at all. The planning and execution logic is determined by the agent at the runtime. As you can imagine, these systems are more robust and adaptive to change. And level 4, agentic AI systems. Now we are talking about a group of level 3 AI agents. They are trying to mimic a high-performing human teams. They work together to tackle more complex problems. Okay. For the rest of the talk, we are going to focus more on level 3 and level 4. On this slide, you can see the 3 key components for single AI. There is an orchestration layer. It's basically you are submitting the goals, responsibilities, you are submitting the system prompt. And then there is a large language model layer is responsible for reasoning capabilities. And there is a tools layer. For product engineering, the tools layer is very exciting because we are talking about the CAD software, the simulation software, manufacturing platform, real world data sources, and so on. Imagine if you have an AI agent that can autonomously retrieve 3D model information, run a simulation on it, FEA, CFD simulation, or you can reach out to a manufacturing system to retrieve a bill of materials only through natural language requests, right? This is exciting. And on the top right, you can see now, you have a single AI. How about using a group of AI working together? The key design principle here is specialization. So instead of building a one massive monolithic AI agent that tries to do everything, it's better you build a team of focused AI agents. Each of the agent is expert of its own domain. This approach can make sure this whole system is more maintainable, more reliable, and more powerful. Okay, and on the lower right, you can see how the agents can communicate with each other. There are different communication patterns. For example, there is a supervisory model that you can define a manager or supervisor role of the agents. And there is a network pattern. Basically, each agent can communicate horizontally to all the remaining agents. So the red communication pattern depends on the workflow you are designing. With that being said, let me show you in a quick demo. This is the kind of a hello world type of example, just show you what an agent can do. This is a CAD agent. The agent is connecting to PTC Onshape. If you're not familiar with Onshape, it's a cloud-based CAD software, which is running on AWS exclusively today. If I play this demo, you can see on the left, you have a natural language, user interface. And on the right-hand side, I just want to show you the software. So theoretically, you don't need to open the software because agent can do the work over here. You can ask the agent, hey, how many models I have in my Onshape environment, right? It's going to tell you have 2 models and return with the metadata about the model. And now you can dive deeper into a agentic question. Hey, can you build a 3D model for me on Onshape? This can be a hello world example, like let's just build a cube, right? Now you can see that there is a reasoning process going on and agents start interacting with Onshape and start building the system. In a few seconds, you will see the agent build a cube with a default like edge length of 25 millimeter because we didn't specify in our natural language requirement. You can see in this whole process, there was no manual CAD commands. There is no scripting, no special syntax. You just tell the agent what to do. Here we go. Yeah, this is the cube agent build in the Onshape environment. Okay. Okay, let's dive deeper into the agentic AI tech stack. By the way, this is the cloud-based tech stack. I want to mention, there are 3 layers. At the bottom layer, usually, at AWS, we offer different CPU, GPU, HPC instances for engineering, design, and simulation workload. We also offer the custom silicon, training inferential chips for AI model inference and training. And many customers they use Amazon SageMaker to build and fine-tune their own AI models. There are HPC services like batch, like parallel computing services for you to scaling your product engineering and simulation workload. Moving up, you can see there is a Bedcore there is a Bedrock agent core. I'm sorry. For Bedrock Agent Core, this is the new service we launched last year. It's basically eliminating undifferentiated heavy lifting for you to build and deploy agents on AWS. It handles the runtime, the memory, observability, and identity, all the challenges I mentioned before. Now, further moving up, for large language model, you can use Amazon Bedrock or Nova. And for the engineering tools layer, this is very interesting because we saw a lot of people they use Bedrock agents to handle the multi-agent communication, and some of them they want to be more flexible, so they're asking, hey, can you support open source like Longchain, LangGraph, Crew AI, or even our Amazon Strengths Agents SDK? Those are all the open sources we can support. Moving up to the tools layer. So a key question is how do we teach AI agents to be able to use all the engineering tools out there, right? Of course, you can build a custom connector through MCP server, but you need to realize that's a lot of investment on your side. So this is why we highly recommend working with our partner Synara. Synara already have this low-code agentic AI platform, and they have around 80-ish connectors to the most commonly used engineering software packages. As far as we can tell today, they are the only solution in the market which is purposely built for engineering design workload. And to realize this is not a small thing, okay? This is the difference between whether your agent has hands to do something or not. Let me move on. Due to the time, I'm not going to dive deep into this RFQ demo, but basically, there is an air filtration system. From the time we receive the customer requirement to we can provide a quotation, it's usually take about 3 to 4 weeks. So here, jointly with Synara, we build a multi-agent system. As you can see, there are 6 AI agents. Each of them have their specific roles and responsibilities. They have their specific data and tool sets they can access. There is a QR code which link you to a blog we published, and there is a video demo associated with that. So please take a look if you want to dive deep. Here, I want to show you another scaled up demo from our customer Blue Origin. I really like this demo because Blue Origin is not just experimenting with agentic AI. They went all in, right? They built more than 2,000 AI agents across the company. Within 1 month, they have more than 3 million AI interactions, and the company-wide adoption is more than 70%. So the hardware they built, as you can see on the chart, is called T-Rex. This is not a dinosaur, stands for Thermal Energy Advanced Regolith Exchanger. They built this through Blue GPT, which is their internal agentic AI platform. The idea here is, hey, to build this system, now we only need 2, 3, smart, brilliant engineers work alongside with AI agents. They can really finish the work within days, like previously need to take dozens of engineers within months, right? So this is the true scale we are unlocking. And this is the true scale that you can imagine AI can help human to achieve in the future. Okay, with that said, I know many of you may be interested in building your own agentic AI systems. Here are some best practices to actually keep in mind. Firstly, I want to say don't skip the theory. This sounds very obvious, but it's hard to do. We see a lot of organizations that dive into the multi-agent system without understanding how a single agent will work. So make sure you spend time, understand the foundation before you're adding complexity. And also, multi-agent system is its own discipline, right? How the different agents can communicate, what communication patterns are available, whether you are building the workflow towards more autonomy or more deterministic. These are all the design problems you need to think about. Secondly, build observability from the beginning. So one known issue about agentic AI system is they don't like, the other traditional software. They don't give you a explicit error message when something is wrong. Okay. So an agent can still finish the work you assign to them, but this may be slightly different from what you need, right? This might be due to the agent is reasoning in a wrong direction, or it's calling the tools in an unexpected order, or they're producing some results technically looks good, but this is not what you want, right? So you need to make sure you have the visibility for each agent at each step. And the third, I would say, be deliberate about the trade-off for the output quality versus the latency. As you can imagine, each agent, each loop, they're adding time and cost. So the trade-off between whether you need better performance or you need good enough performance to save time and cost, right? So you need to be deliberate about that. A lot of times when you're adding more agents, adding more loop, it doesn't necessarily improving the output qualities. And the last one, design for augmentation, not replacement. We have seen the most successful AI agent deployment is when they are designing around human AI collaboration instead of one replacing another. You can use agent to do initial research, data gathering, and for human to validate, to refine, to make the final decisions. So just keep in mind, when you're doing the optimization algorithm, making sure they're optimizing based on this human AI interaction. Okay, this is my last slide. I want to show you guys a little bit outlook about where agentic AI is going in the next few years. The first frontier we call deep agent. Think about the RFQ process I mentioned to you. We need to purposely build 6 AI agents, right? But think about this use case. How about you just build one AI agent, which is the supervisor agent, and then give the supervisor agent a big scope of work. Let the supervisor agent to create the sub agent by itself. Basically, you are letting AI agents creating other AI agents. So this is very promising, as you can see the efficiency gain in the future, right? Second frontier is called autonomous R&D. We have seen this in material science, drug discovery, advanced manufacturing, because a lot of agents can do hypothesis generation, experiment execution, and then they can do an iteration loop around that. So this is a potentially reducing 10 years of work into a few years. This is the paradigm shift. And then the third one is called social technical AI. A lot of people call this organizational AI or institutional AI. Basically, the future system will be embedded deeply into the organizational fabric. They will accumulate institutional memory over time. Think about if you have employees leaving the company, then not, there you have knowledge gap, right? But the social technical AI will be able to surface the relative historical decisions, historical design solutions, or risk analysis from the past that can match the problem you have today. Last one is called ambient AI. Some people call this invisible AI. This is the always-on intelligence. So I think this is a little bit long-term shift because we are talking about intelligence that will disappear in the fabric of the engineering environment in your operating system. They become a persistent infrastructure. It's simply there. It's always run. It's always on all the time. From this side, and human engineers will be shifting from human in the loop. You have to manually trigger everything to human on the loop. So you have the AI running continuously and human can decide, set up checkpoints to finish the final decision making. With that, I highly agree what Jill just mentioned. It's not the time you should be thinking about whether I should use agentic AI or not. You should be thinking about how do I use agentic AI well. Okay. Again, I'm excited to be here working with partners like Synera, Neuroconcept, Autodesk. My email is on the screen, so feel free to reach out and I'm happy to connect. Thank you very much.
Thank you so much, Ryan. That was an amazing presentation. And there are some great questions that came into the feed. To respect everyone's time for this event, we're going to move on to the next presentation, but we'll be sure to get responses to all of your questions. I have about a dozen for you as well, Ryan. So we're going to have a side chat someday.
Sounds good. Thank you so much, Richard.
All right. Thank you, Ryan.